We have a special notation to use when we're dealing with partial sums, and it's called summation notation or sigma notation. We call it summation notation because it's a way to designate a sum, and we can call it sigma notation because it uses the Greek letter sigma. And the way that we write this is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 all the way up to a sub n can be expressed as the following. We have the letter sigma. On the right-hand side, we have a sub k, because the things that we're adding all look like a sub k, and k is changing in each of the terms. K starts at 1 because we've got a sub 1, and it goes all the way up to n because we've got a sub n. So we read the right-hand side as the sum of a sub k from k equals 1 to n. And the thing that's changing in each of the terms is the k, and that ranges, again, from 1 to n. The letter k is called the index of summation, and the idea is to replace k in the expression with the integer 1, and then 2, and then 3, all the way up to n. The number below the sigma is the smallest value of k that we use, and then the number above the sigma represents the largest value that we use. Let's look at a couple of examples so we can see exactly how sigma notation works. Find the sum of k squared as k ranges from 1 to 4. What this means is we're going to add a bunch of terms that look like k squared, but k is going to be different in each term, starting with 1 and going all the way up to 4. So this means we have 1 squared plus 2 squared plus 3 squared plus 4 squared. Once we've written this out, we can actually go through and add all of these together. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and when we add all of these together, we end up with 30. So that sum gives us 30 in the end. Let's take a look at another example. Find the sum of 1 over j as j ranges from 4 to 6. This is a way of expressing the sum 1 over 4 plus 1 over 5 plus 1 over 6. To add these together, we know that we need a common denominator, and the least common denominator here is going to be 60. So we need to rewrite all of these as fractions with 60 in the denominator. 1/4 is 15 sixtieths, 1/5 is 12 sixtieths, and 1/6 is 10 sixtieths. When we add these together, we end up with 37 sixtieths. The sigma notation is basically a way for us to write a sum where the terms are very much related to each other, but in a shorter way. Let's take a look at one more example. Find the sum from I equals 5 to 10 of I. This means that we're adding I over and over again, but I is going to change from 5 all the way up to 10. So this means 5 plus 6 plus 7 plus 8 plus 9 plus 10. And when we add these together, we get 45. Now, in each of these examples, it probably wouldn't have saved us any time to put things in sigma notation when we could just write out what these individual sums are on their own. However, if we were writing something that had many terms, there are many situations where it's simpler to use sigma notation. For example, if we wanted to write out the sum, the square root of 3 plus the square root of 4 plus the square root of 5 plus the square root of 6 plus the square root of 7 plus the square root of 8 plus the square root of 9 plus, continuing on all the way up to the square root of 99, that would take quite a lot of time to write out each term. However, we can use sigma notation to write it out a lot more cleanly. Here, each of the terms is the square root of a number, and in this case, the number that we're taking the square root of ranges from 3 all the way up to 99. So this is a way that we can take a sum with many, many terms and rewrite it in sigma notation so that it takes up a lot less space and so that we can see exactly what's going on. Here I is ranging from 3 all the way up to 99. We don't have to guess, whereas here it might not be entirely clear what's going on if we're going all the way up to 99 or if we're skipping terms or something like that. So it's just a little bit more of a precise way to write a sum like this.